Hello everyone. Today I'm back with another challenge for you. Go ahead and pause the video to try this one on your own. It's a great way to sharpen your problem solving skills. Once you are done, stick around until the end to verify your answer. So let's get started. In order to solve this question, you should know what is solvolysis. In organic chemistry, solvolysis is a type of either nucleophilic substitution or elimination reaction where the nucleophile is a solvent molecule. For example, if water is used as a solvent, then it acts as nucleophile as well. Water, which is a protic polar solvent, helps to stabilize the reaction intermediate if any reaction intermediate is formed during the reaction. For the given compounds, we need to arrange them in the decreasing order of their rate of solvolysis. That means what? If the reaction intermediate is carbocation, then how better that carbocation is stabilized, it shows the rate of the reaction. Better the stability of carbocation, better will be the solvolysis, hence highest will be the rate of solvolysis. Therefore, for the given molecules, we need to first polarize the molecules, write the reaction intermediate, and then check for the stability of the molecules. When the given compounds are taken in solvents like water, methanol, ethanol, they do undergo heterolytic fission. What is heterolytic fission? Let's take the first molecule and understand the reaction happening here. Since bromine is electronegative element, it withdraws both the electrons. That means what? It takes away the bonding electrons and it will leave the molecule as bromide ion. Then what happens to this carbon? It will become electron deficient. If it is electron deficient, the charge would be plus. That means what? It is forming a carbocation. Therefore, carbocation is the reaction intermediate in the reaction. And breaking of this carbon and bromine bond is a slowest step. Hence, it is a rate determining step. Why this is important here? Because in the rate determining step, the reaction intermediate is formed. That means what? More the stability of this carbocation, more will be the rate of solvolysis. Therefore, you have to write down the carbocations for all the molecules and check for the stability of these carbocations. More the stability of carbocation, higher will be the rate of solvolysis. Therefore, let's write down the carbocations, the corresponding carbocations for the given molecules. So when the bromine goes here, the carbocation will be formed here for the second molecule, which is a tertiary carbocation. For the third molecule, you see, again it is a tertiary carbocation and it is allylic as well as it is a part of a aromatic ring. Now let's check for the fourth molecule. The fourth molecule is also allylic, but the carbocation is part of the anti-aromatic molecule. Why am I explaining all this? Because it will help us to know how the water, right, the negative part of the oxygen is going to stabilize the carbocation. That is nothing but solvolysis. So among the given four carbocations, so this is 1 and this is 2, this is 3 and this is 4. Among these four carbocations, the third carbocation is the highest stabilized carbocation. Why is it so? Because it is a part of the aromatic ring. It is cyclic, it is planar, there is a conjugation, and it is obeying Huckel's 4n plus 2 rule. Therefore, this is more stable. That means it is undergoing highest solvolysis. So, 3 is the highest. Which is the least? Whichever is part of anti-aromatic. As I told you earlier, this is anti-aromatic as it is cyclic, planar. There is a conjugation and it is obeying Huckel's 4n rule. So this should be the least. Check if there is any such option. Third will be highest, fourth will be the least. We have B as well as C. So that means what? We need to find out for 1 and 2 also. Now, whenever the carbocation is at the bridge carbon like this, it is considered as less stable because this is a non-classical carbocation. So it's having some rigidity over here. So that means what? The carbocation cannot be a planar. So whenever the carbocation is there, it is sp2 hybridized. If it is sp2 hybridized, it's supposed to be planar. But here it cannot be planar due to the rigid structure which is making it less stable. Therefore, we have it here. So which is better stable now? This one. So it is tertiary carbocation. It is stabilized by inductive effect as well as hyperconjugation. So this is the correct order of solvolysis, which is purely depending on the stability of the carbocations formed. And where do we have it? We have it in option C. Therefore, the right option is C. Thank you for watching this video, and I have given a question at the end of the video similar to what we have discussed here. Please do solve it to master the concept, and don't forget to comment your answer and verify.